At this time, I would like to introduce today's presenter, Paul Robichaux. Paul, you're muted.
Okay, Jerry, can you hear me now?
I can.
Okay, great. Thank you very much. Okay, so as I was saying, thanks for setting this up, Jerry. It's really greatly appreciated. And I want to thank all of you for coming out and joining us today. As Jerry mentioned, and as you saw in the invite to this presentation, we're going to talk about ZOS visualization and ZOS modernization. And the goal of this presentation originally was to impress upon third-party software vendors the need to move forward with programs that would enhance the visual appeal of their products, because I believe it's a necessary step for all of us to take as we move forward to try to stay in lockstep with all of the improvements that IBM is making, specifically those that relate to Next Z, which is going to come towards us in the next 2 years or so. The general idea here is that as we embrace visualization, we do it believing there's a payback to it, that it will in fact move the needle. But we can't do it just haphazardly, because it will be disruptive. And in some cases, it will be frustrating. Just getting people moving forward in your organization, if you are an ISV, towards this goal can generate some angst on the part of lots of different people. We have customer support that are 3270 bound, that are legacy oriented in their mentality, and have not yet been able to make the jump to the impact that visualization would have on their organizations as they manage their ZOS systems. Of course, one of the goals in all of this is to broaden the use of our products in our customer organizations, and to create a sense of appeal to the ZOS environment on the part of new people who will be coming along, replacing all of us as we age out. So it can be frustrating, there's no question about that. But it can promote convergence in your data space. Our data space essentially is ZOS and those aspects of security that surround it. But there are many other elements which we have yet to include in our 3270 environment and interface, simply because creating those interfaces was too difficult or wouldn't allow us to share information visually with our users in the way in which you'll see in just a few moments. All of this results in a new form of actionable information. This is not just prettiness for prettiness' sake. This is making things visually attractive and appealing and informative, because we believe in doing that, that people will be more inclined to investigate, to explore, to show interest, to continue exploration simply by following links that lead them to on orthogonal paths in some cases, and perhaps deeply drilling down into certain data items that will give them a better insight into what the ZOS system is and how it is configured. From our perspective, things changed in the way in which you see on this screen. On the left-hand side, of course, is the conventional legacy 3270 green screen interface, as it's referred to. And on the right-hand side is that same interface, but shall we say brightened up to be supported on the World Wide Web. Many additional options are available now in that interface that are not available on the 3270 environment. Of course, we'll support both, but look for convergence of many other data points when you are dealing with the World Wide Web. Of course, we can't do this alone. There are certain strange parts of this idea of modernization that sometimes will exceed the capability that you have inside of your organization. And so if you are a third-party vendor and you want to pursue this, establishing partnerships is going to be critically important. This slide introduces you to three of our partners, Maintegrity, NetSpy, and Henry Kuiper. NetSpy and Henry contribute ongoing pen testing of our web-based interfaces to ensure our users of our commitment, ongoing commitment to ZOS system integrity. And it's through their work that we are constantly able to identify and discover things that might be potential vulnerabilities and essentially fix them. Maintegrity, for its part, contributed the core web server that we use as part of the ICE platform. It is a proven piece of technology, been around for quite a few years, used as part of Maintegrity's MIF Plus tool that is used for identifying file integrity issues. So these three partners helped us to get to where we are today. What we learned along the way from all of them is that there's a lot more to web-based applications than just simply relying on ZOS authentication. There are things that are additionally needed. For example, the establishment of a content security policy that will strictly enforce the relationship between the browser and the server, which will be on MVS. There also needs to be additional applications of multi-factor authorization because of issues like autofill from a browser or from robots that might attempt to hijack the website itself, and many others that you see here that we can go through in great detail if you decide that you need additional information here. So these security policies and security attributes will sometimes seem strange and different. They are the kind of policies and attributes that risk managers and lawyers and auditors and those that investigate systems are very highly interested in. And I'll show you some ways in which this has been documented inside of the platform itself. The net result of our work with our partners and our work internally was that we merged the ICE web server with the ICE main task. What that gave us when we were finished with that work was an application platform. That platform is delivered as a web-enabled ZOS platform. It's delivered as a single encrypted download file. From our users' perspective, it's no different than the way in which they have become used to downloading and installing what we refer to as IFOM, our ICE main task, over the last 20 years. It's exactly the same. What it contains, however, is quite unique. It contains an MVS web server, which means that once they are finished with the install, they have actually stood up another web server inside of their environment that's totally based on MVS constructs. There's no need to stand up Apache or Tomcat or Liberty. There's no need to fire up a Linux server or any of that kind of stuff. This just simply installs and immediately goes to work. There are obviously connective issues that are relatively straightforward to solve. Opening a firewall, declaring a port, implementing ATTLS or IPsec security. They're all part of this, but those kinds of things are well understood to most users. What is often quite difficult and overcome by the strategy that we chose is the standing up of an additional web server in your environment, and having complete understanding and control from the vendor who's going to use that server, that they understand what it is, what its vulnerabilities might be, how those vulnerabilities are being addressed through the content security policies that that server houses and distributes to the browser itself. Once the platform is in place, then it would take the vendor down the path of populating the platform with applications. Those applications might be applications like image focus inspections or image focus or TCE resource maps or event journals or TCP/IP inspections. But those applications can also be things that revolve around the ZOS data space, like the health checker or display commands or IODF analysis or SVC analysis. Or alternately, but collectively and convergently, it could include the RACF data space, setter ops class descriptor analytics, command capture and auditing, and digital certificate analysis. And we'll share some of these applications with you today. But today, within the ICE Direct environment, we have about 30 different applications which are hosted on the platform and plan for more. The appearance is going to be quite different from what it is that you've seen from us in the past. It is highly energized, it's highly colorized, it is intended to invite exploration and examination. And in some cases, as you'll see, it will also allow you to proactively take action to reconfigure or update or add to a particular environment. In this case, we're talking about the RACF environment that I'll demonstrate here in just a moment. Another thing that we embrace, and I know not all of us feel the same way about ZOSMF, but we believe that with its requirement for 2.5, that it represents an opportunity to embed a layer of security in accessing the web through a third-party vendor's application that is otherwise not available if that web server and its browser interface are accessed directly from the browser itself. ICE Direct integrates directly into ZOSMF through the ZOSMF links. We know the security that surrounds ZOSMF. We know that the links can be SAF protected. We know all of that stuff, and we can't turn our back on it. We have to embrace that because what we really want is a companion to ZOSMF. We want to stand side by side with them so that it's possible for a user essentially to toggle back and forth between the two environments without interrupting the workflow on either one or the other. So with that said, I'm going to click on this ZOSMF-based demonstration link here and launch ZOSMF. And I'll go ahead and log on. So I'm authenticating into ZOSMF or into ZOS. User ID and password. And I'll go ahead and log in. Now, what you see on the screen right now is not something you're going to find in existence much longer, but I'm using it just for demonstration purposes. This is referred to as the classic view. There is another view, which is called the desktop view, which is more iconized than it is associated with pull-down menus like this particular interface is. But I do it to indicate that you can establish links to more than one ICE Direct location. And so if you are in the UK and you have a site, let's say in Mexico, or another one in Spain, or yet another one in China, or wherever, and you are running ICE Direct in those locations, you can link directly to them from this links menu so that you could actually move between sites in order to do work on each one or compare results on each one against the other that you might be also logged on to at the same time. So I'm going to go ahead and click on ICE Direct. Now it's going to ask me to re-authenticate with ZOS, and that obviously is something that needs to happen because I'm now going to connect to a different ZOS system. ZOSMF is on system A, And now ICE Direct is on system B. So I'll go ahead and log on or re-authenticate with ZOS. Okay. All right. So now I have taken the first step towards actually logging on to ICE Direct. I have authenticated with ZOS, and it has in turn allowed for this panel to be displayed. Now, what this panel is doing is it's enforcing multi-factor ICE, which is another form of multi-factor authentication. Multi-factor ICE works with the external security managers, the RACF, ACF2, and Top Secret. And when it was called, it asked them to generate a one-time pass token. And it did. And we extracted from that token material 4 characters, which you see on the screen, SELM. Now, what has to happen here is that myself as a user had to pre-register, or an administrator had to pre-register for me a PIN that I'm going to use to prefix that material in order to move to the next location. Now, there are many different options here. The entire token could have been sent to me via email. It could have been sent to a third party that I would have to cooperate with. But the one that I think most people will appreciate the most is the idea of multi-factor authentication in real time, working in conjunction with the external security manager to generate the token material and allowing me as a user to register with the system a PIN that is encrypted and stored much in the same way as a RACF password, and then use that, change it whenever I want, use it as a method of entry into the system. So I'll go ahead and enter my PIN. And let's see, SELM, and I'll authenticate. So now we have these multiple authentications. We authenticated with ZOS. Now we've authenticated with ICE. And now as a result of that, the primary ICE Direct frame set is displayed for me, introducing the opportunity for me to proceed. So just a couple of things here to point out as we go forward. One thing that we feel is very important is for a user who is using ICE Direct to know exactly what rights and authority they have within the ICE Direct environment. And so in this case, when I click on My Who, it's actually answering the question, who am I? Well, I am a prime administrator, and I'm also an auditor. I'm sitting at the highest level, the pinnacle of access rights within the ICE Direct environment itself. But none of those rights override any of the permissions or rights that are granted to me by the external security manager. The external security manager, RACF, ACF2, or Top Secret, is sitting there on the ZOS system, monitoring everything that I am doing by my user ID and permitting me and granting me only rights that I have as it sees it, not as ICE Direct sees it, but as it sees it. As I go down through this and I click on my history, you'll notice the little gray rectangle on the left-hand side and what we refer to as the sidebar is moving along with me so that I can always see exactly where I am within the interface itself. Now, I've got this particular panel set up to give me an analysis of what I've been doing since 11/15. Now, you likely already know that the web is really stateless. That is, nothing gets remembered. But in the ICE Direct environment, our user registry is tracking everything that the user is doing. And so it knows what the values were in this panel the last time the user was on board. And so every time that the user updates these panels, it's remembered and then refilled the next time the user comes around. Typically, we'll have an opportunity to see a report or we can see things graphically in the form of a donut. So let me go ahead and click my query. It's important for users to know what the system, particularly a system that's focused on control and security like the integrity controls environment, for them to know what it is that this environment knows about me. It's kind of reminiscent of my early days in ZOS when my boss would say, now when you log on to TSO, be sure you check that date and time for your last log on to make sure that somebody didn't come in behind you and log on. Okay, well, I didn't do it perfectly, but I did it sometimes. And I thought it was a good idea. And this is kind of the same idea. Now we can see here that I've been doing a lot of stuff with the external security manager, 950 commands that I've issued over the last few days, doing some testing and development. Some other stuff that has taken place and some other stuff that's taken place. Now, when we look at the other stuff and we don't know exactly what it means, you'll always find at the bottom of these graphics a legend that tells you exactly what the user has been doing, what these values actually mean. Another thing that you'll find at the bottom is an elapsed time indicator. Now, in order to generate the information that was used to populate this particular donut and then send it back to the browser and display it, it took about 6 seconds, okay? Now, that seems a bit long. That's not instantaneous sub-second response time. Users of this product on real mainframes report that they are seeing performance that's 10 times better than what I am showing you or you will see here today. So just a couple of things here. The multi-factor ICE and the token itself, we can change the token here if we like. Just simply put the old token in, the new one, and confirm it. We also have a form of a similar process that we refer to as multi-factor edit. It's part of our zero trust architecture that provides specific boundaries around critical ZOS resources like ParmLab, for example, or certain members within ParmLab. And we can do the same thing here. Okay, we can change that PIN if we choose to do that. So enough, a little guy on the left is referred to as the sidebar. You can see that when I select it, anything, it clears the lower frame, which we call the results frame, populates the upper frame, which we call the directs frame. Now, many of you are quite likely using IFO BAT, so I'll click on that. And IFO BAT is, as it sounds, a batch job. Its job is to do inspections of any number of LPARs that are either locally or remotely identified to the system itself. I have 5 identified here. You can see the worksheet value of 5. If I want to increase the number of inspections that I'm tracking, I just simply raise the number. When I click submit, what it does is it goes off and it gets all the data sets that contain the inspection logs for those 5 different inspections, analyzes them, and comes back and gives us this display. Showed you this earlier. From here, we can do all sorts of things. For example, for those that might not be fully aware of the processes that are used in the IPL, that is the IPL path and the IPL steps, we have a process that allows us, in essence, to see that. So here we see it visually. We see at the top of the panel, those things, those members that are processed during NIPS. We see in the blue color, those that are processed in IEA SIS. And then down at the bottom, we see those things that are related to subsystem functions, which are initialized after we have a fully initialized ZOS core. You notice to the left of the member names, there are little icons that show, in essence, the status of each one of those members. This is an interesting display, but I like it better when we sort it by last update. We can do that. The reason for this is because if there is an issue here or if there is a need for exploration of what changes have been made to this particular IPL path since a certain time, this will give us access to it. So for example, we can see that the load WS ParmLab member, which shows up at the very top of the list, was the last member that was updated on May 21st. This way you could quickly see, okay, what changes are being made here. Let me see them by member. You can find them here. We can see that BPX PRM, which was updated on April 15th, has a problem. So let's click on the little warning sign and find out what it's complaining about. Well, if we scan down through the member itself, what we'll see is that there's no construction or syntax error here. What we're complaining about is that there is inadequate data set protection of the data sets that are actually named in this BPX PRM member. Now, if we go back to the top, we can see an integration between this function now and the control editor. So if I click member journal history, it'll come back and say, yes, okay, I understand. You want to know what the control editor knows about any changes that may have been taken place to BPX PRM. If we click on the 4, we can see in a push down stack the last change that took place on 4/15. We subdivide the content of this panel into those things that are backups and those things that are event journals. If we select the first one, we'll see exactly what changes were made. And this is just some nonsense stuff to drive the process itself. And then we'll see the actual member. I didn't point out this, but there are 4 BPX PRM members that are in one volume, are on one volume, and there's one that's in another volume. And this identifies that in the legend. It says, this one is in this ParmLab member on this volume, this one's in that ParmLab member on that volume. If we go back and I now click this and change this to an asterisk and press enter, we'll see all the BPX PRM members that are in the control journal, the data set that they're in, the volume that they're on, and you can then drill down into them from here. One last point here, if I click to the right, what I'm doing here is the equivalent of a 3.4 against this particular data set. And when I get it back, I can see it listed. It's a nice list, but I like it better when it's sorted by update. So I'll click update. And this tells me what member was last updated in this particular data set. The last one was the clock on 11/6, makes sense for the time change. And then you can see after that, the next one was BPX, our command PH, et cetera, all the way down to the bottom. So this is just a sampling of the functions that are available to those that are using IceBat. Let me click here in the crossbar. You'll see a value here called my host, SOW1. That's the name of my system that's hosting me. You'll see some information about it and the port and the URL of the IceDirect platform itself. You'll see information about when it was last IPL'd, et cetera. From here, we can drill down even further into the configuration itself, showing what products we're licensed for, what subproducts we're licensed for, and then other functions. Now, here's one I mentioned earlier. This is browser policy. This is something that has to be highly transparent, has to be readily available in real time, not just a script that says, this is what we do. This is the script that says, this is what we do, and here's how we're doing it right now. We click on it. What it will do is it will reveal all of those attributes and policies that I mentioned earlier that we learned from our friends at NetSpy and from Henry Kuiper. And here they all are, every single one of them, even to the extent that when we are making exceptions, recommended exceptions by our experts, we are detailing those exceptions and the actions that we have taken to mitigate them. This is something that lawyers, risk managers, auditors will all want access to. So you can provide that by just clicking under File, go to Print, go to PDF, open in Preview, and the document is now displayed as a PDF document. You could send this by email, you could store it or save it if you want to. All the values that are in it, for example, like the CRSF token, this is the real-time value of that. This is not just a made-up value, this is the real-time value. Up here at the top, the value of the token itself, this with its last 4 digits blanked out, is the real-time value of the token that is a component of the cookie that makes up the overall session token. If we scroll down even further, again, I'm doing this in a PDF. This is the token that's used with JavaScripts that are embedded in the interface itself. We have no inline scripts whatsoever that can function without a nonce. And the nonce is unique to each instance of each script and is validated by the server to make sure that there isn't any script injection issues that might occur. Now, let me go back up here and now click on RACF. Now, here we see RACF functions, an audit of or an inspection of the RACF settings, digital certificates, command history, and a RACF service desk. This was sort of like a help desk function. If I click on the little life preserver on the right-hand side, what we'll see is something that's common throughout the ICE environment. These are help panels, and they are populated essentially everywhere. But this one is particularly important because what it says is to answer a common question, what is the required authority to use these 4 functions? Well, in order to use these options, you will need RACF special or auditor or read-only auditor authorization. And in addition, you will need to be an ICE prime, an administrator, an ICE auditor, or an ICE read-only auditor. Without this dual authorization, you will be denied access to these functions, okay? So this is not something that a user can casually drop into. This is something that a RACF auditor or someone with RACF special who also has equivalent credentials within the ICE environment will be able to gain access to. Now, if I click on RACF settings inspection, we're drilling down here into the class descriptor table. Now, the class descriptor table is a function within the SetROps environment. If we want to see the source that we're using here, we can click on SetROps source records. This is common for us to display transparently the information that we're using as the base jumping off point for more detailed analysis. And so you can see here, this is the classic SetR listing. It's beautified a bit, but it's the same thing, broken down into various areas. If you wanted to print this, of course you could. Now, if I back up, we'll see something a bit more intriguing. If I click on active classes, we'll go off and find all of the classes that are associated with the descriptor whose name is active classes. But in addition, we're going to check each one of those active classes to determine whether or not it might be rack listed. And if it's both active and rack listed, it will show up in green. If it's just active but not rack listed, it'll show up in blue. Okay, so that's sort of interesting. But down below is another button, which is called Audit These Classes. Now, when I do that, what we're doing now is we're laying another filter on top of that matrix so that we can identify some additional attributes that are associated with each one of those class names. Again, our users indicate that their performance is typically 10 times better than this. So my server is in Las Vegas, I'm at home on the internet, blah, blah, blah. Not an excuse, but that's just the way it is. That took 37.38 seconds to do. What it did, in addition to maintaining its understanding of active and rack listed, or neither, it went off and found those classes that have profiles that have no permits, shown in black, one here, XGFACL. It went off and found those that have profiles that have users associated with them that are no longer known to RACF. We call those orphans. And then it went off and it found those classes that have no profiles. And it's identified them all for us here by color. If I click on facilities class, which is indicated to have some orphans, and the impression you should get here is we're drilling down deeper and deeper and deeper into the RACF database. And we're doing this against the live database. Again, patience is a quality here. This particular portion of the audit of the facilities class now expands the information that we have available to us. The first expansion is that it takes a look at the policies and rules that govern the various groups that the facilities class might be in. So in addition to being active and rack listed, it's also in the general profile group or descriptor. It's also in the general command descriptor. It's in the global check descriptor. It's in the audit descriptor. So it's in a lot of different places. It's not just in the active or rack listed classes. It's in a lot of different places. It identified all the users that are associated with the facilities class and produced them in this little matrix. It identified those that are, excuse me, are orphans and those that are not. Clicking on any one of these, for example, let me find mine. Will show a list of all of the profiles that I have access to within the facilities class and which ones of them I am the owner of. So the owner is highlighted in green. My actual ACLs are shown right below that. So me, read this profile, what do I have, update, et cetera, et cetera. So I can get all of that. If Zoom gets out of the way, I'll go back. Thank you, Zoom. Now down below, we see a continuation of the inspection. In this case, what we're doing is we're looking at all of the discrete profiles within the facilities class. And you can see them all listed here. You can see those that contain orphans because to the left of them, you will see a salmon colored icon with a number in it showing the number of orphans that are associated with that guy. To the left of that, you will see quite likely either a blank or a yes. The yes indicates that in addition to this discrete profile, there's also a generic profile that matches it. And to the left of that, we will see the UACC that's associated with the profile. And then to the left of that, we will see the actual profile owner. And scan all the way down. To the right shows us the number of users. We could add a discrete profile to the facilities class if we wanted to at this point, just by clicking that. We can add them 5 up if we choose to do it. No problem. Here we are in the generics. And here again, we have similar yeses and identifications and so forth and so on to let us know that there might be a discrete that matches this particular generic profile. Now, if I go back, BPX daemon is always of interest to people. It's got some orphans in it. I'll go ahead and click it. And here what we've done is we've drilled down into all the ACLs for BPX daemon and broken them down into 2 columns. One of the columns is unconditional access rights, and the one to the right of that is conditional access rights. The black icon with the 0 in it, or the O in it, indicates that I am the owner of this particular profile. So we indicate if there's a universal group or not. We allow you to, if you choose to go through the steps to actually delete an orphan or to delete any user that happens to be in a particular profile. So in this case, we could begin the delete process of IBM user. In our system, we have what we refer to as a descriptor. You can make this mandatory if you choose to do it. I like to think of it as part of the zero trust architecture, protecting those that have the rights to be able to perform these kinds of functions, people with special, in this case. Auditors couldn't do this. Auditors, if they chose this, would see a panel that looks like this. And you can see here that this doesn't have any additional functionality on the bottom of it, which would allow them to go through the process of permitting or deleting or any of that kind of stuff. Okay, so I think you get the idea. We're just drilling down, drilling down. We have a bit more to show here. Data set processing options. These are audits. Julie Berg, who some of you may be familiar with, is helping us with this to identify the attributes that we believe are best practices. You can see how those are being illustrated in this. Automatic data set protection. If I click that and I wasn't happy with that, then I could go through the process of cleaning that up. Okay. You can see here that the words don't match the algorithm at this point. It says no ADSP is a best practice, but yet we have it set at that, and we don't have that yet taken care of. So we will. And therefore, auditors is a full compliance with best practices across the entire SetROps structure. Now, let me go back up to the top here and click on RACF certificate inspection. I think you'll find this interesting. Now, what we're doing here is we're asking RACF through RACD-Cert to give us all of the certificates. And much like we do with SetROps, we have a disclosure for transparency purposes that will show us the source that has come from CertAuth and CertSite requests. So here's that disclosure. So at the top of this, we have digital certificate information that came from a CertAuth list command. And at the very bottom, if I can get to it, sometimes not as easy as it looks, I also have the same information for a site request, for site list. In this report are 1,212 records, 47 certificates, 21 of which have reached their expiration point. When I back up, And now I'm looking at the 4 steps that we're going to take in our audit before we actually examine each profile or each certificate label individually. So the first thing we're going to do is we're going to examine certificate owner rings. And we're going to determine if any owners of rings have rings that potentially have expired certificates. For example, START. START is the owner of rings. In this case, START owns 4 rings. You can see the 4 of them there. And you can see that one of them, JES2 EDS, has expired certificates in it. And that's something good to know, something that you might want to take action on. You can see in the ownership here, we've gone beyond cert aut and site. We are now picking up IDs specific to the owners themselves and their specific certificates. If I click on that, I'll get this specific certificate, which is specific to the ID Start 1. You'll notice that we highlight the fact that the end date has been passed, and so this is not a functioning certificate. We look for signing algorithms, key types, and key sizes as well, which I'll show you now. So now we're looking at what would we consider to be an appropriate signing algorithm. Well, we can look at it this way, or we could look at it in the form of a donut. And when it comes back, it says, okay, well, you've got these different signing algorithms. If we click on SHA-1 as an example, it'll tell us SHA-1 is not particularly appropriate. And there are some certificates that use SHA-1 that have expired and some that haven't. So the expired ones we may not care very much about, but the ones that are still active we might care about, and we might want to do something about that to update them. We do use a lot of color in here to indicate different things, but we're also populating this with icons and other indicators for the visually impaired. You can see one of them in the corner with a little thumbs down there. The next thing that we look for is key type to see if it's adequate or not. These all appear to be. We then look for key size to determine whether they are adequate or not. And we can see that, at least in our algorithms, anything that's less than 2048 is considered potentially an exposure and something you should do about. Below those 4 inspected items, we have now a complete inspection of all of the certificate labels that we were able to get from Cert Aut and Site. And you can see those that are indicated as having been expired. You could also see those that are going to be here in 30 days or in 60 days. You can see the sources of them, whether they come from Site or excuse me, Cert Aut or Site, and you can see whether they're trusted or not from this examination. Again, you can print this off and do essentially whatever you like. You can sort this by date. Again, now we have sorting with one that will expire last, so in 2050, and then we have all the expired ones down at the bottom. And you can see which ones came from Site and which ones came from Cert Aut. There is a function down here at the bottom that says show issuer and subject. I'll go ahead and click that. Now, issuer and subject are critical elements within the description of a certificate that we have in the first panel described by label name. But now we've added to that the issuer, I, and the subject, S, to that, because the issuer name can provide us with a link to DigiCert. And so when I click on DigiCert, it'll go off and it'll bring back the serial number and the issuer distinguished name that form the basis for the profile name in DigiCert that is protecting this particular resource. And you can see this resource exists, but there are no permits to it. We can click on owner. And we can see all of the profiles that are owned, or excuse me, labeled names that are owned by this particular person, this user ID, IBM user, what the serial number is, what the signer authority is, and whether or not anybody is promoted to it or not. So, that's pretty much it. I just want to show you one other thing because we're running out of time. Let's just go do the health checker real quick. One thing that we do is we use XCF to scan the system to pull out all the system names that are in the sysplex that we are running on. I happen to just be in a sysplex that only has one image, but in this particular analysis, you could analyze all of your health checks across the sysplex in one go to see whether or not they are the same across each system that is in the sysplex. Now I'll go ahead and select this and I'll show it in a report. So it comes back and it gives us all of the findings that the health checker has described, even those that are not active, those that are just informational, those that are okay, and those that have exceptions. If we click on an exception, it will tell us exactly what the health checker is complaining about. Okay, all right, I got 5 more minutes. Well, actually, I'm 5 minutes over, but just hang in there for a second. We do the same thing with the IODF. We scan for everybody. We could do them all, but I just have one. I'm on a VM system, so I don't have a real IOCP. So a customer actually volunteered one. I can use the running system, or I can have a working IODF. I'm using the working one. I click on IOCP analysis. We go off, dynamically run IBM utility, CBD, MGHCP, extract the current content of that IODF data set. And we're going to display it in just a second here. So here we have a dark line, which is an indicator of a KEK. This is CPA. There are two. This is the first of 2 KEKs. Below that, we have the logical channel subsystems, LCS 0, 1, etc. All the LPARs that are associated with that are not populated, as the case may be. There's the second KEK. Now, if I go back up to the top, this will be my final thing here. I'm going to click on this little icon here. It looks like a spider laying on its side, intended to denote CHIPIDs. As I mentioned, there are about 35 different applications that are currently hosted on the ICE Direct platform. And you're seeing just a small portion of them. If you have interest, want more information, we'd be happy, very happy to provide that to you. So here we have all the CHIPIDs that are associated with that KEK and what their label names are. We can look for duplicates, and we could sort on duplicates if we wanted to, or we could sort them by CHIPID ID. Maybe that would be more helpful to your understanding of what the channel subsystem configuration looks like. So I hope by now you've kind of got the idea that what ICE Direct really does is it encourages examination and exploration. It allows for actual modifications when it seems appropriate that those modifications should be taken. Okay, so I'm going to go back to my presentation. This is a diagram into the heart of RACF. This is what we were exploring when we went through our class descriptor analysis. And so this is exactly what we did and how we identified it. What we didn't show you is that we can not only identify ACL orphans, we can also identify users that own ACLs that are open, that are orphans. We can identify orphans in groups. We can identify group owners that are now orphans and allow you quickly, visually to clean up your RACF database if that's something you want to do. This is an example that we showed you. This was essentially tied to discussion on the RACF discussion list in 1026. This is the details of the server and how it works, and we can get into that at some point. This will be posted on YouTube along with a bunch of other YouTubes that we have out here or have out there for you to look at. My recommendation is that the one that you should pay high level of attention to is 0. This is patient 0. This is the first person that will log on to your ICE Direct system. Okay. All right, Jerry, that brings me to the end, and I'll turn it back over to you to see if we have any questions.
All right, thank you, Paul. And I want to thank everybody for joining us as well. And if you joined us after we started and you do have a question or a comment for Paul, mouse down to the bottom of your screen and click on the Q&A button and type in your question or comment, and Paul will address it. We'll give you a minute or two to do that. Once again, if you did join us after we started, I will be sending out an email with a copy of the slides that Paul used and also a link to our YouTube page so you can check out the recording and share that with others who may benefit from seeing this but weren't able to join us today. Paul, I'm not seeing any questions.
Okay, well, maybe I did a thorough job, or maybe everybody went to sleep. I don't know what that might be at this point, but I want to thank them all for coming and joining with us today. And if they need any additional information or demonstration, we'll be happy to provide that.
All right, thank you. Thank you all once again. This ends today's webcast. Goodbye, everyone.